Dear students, I welcome you all to this physics tutorial series of the class 11 physics by NCERT. So in this video, we will learn about the instantaneous velocity. What is the definition and how it is calculated? We have to understand this. Okay. So first of all, we have to understand what is average velocity. Average velocity we learned in our previous video. Okay. So average velocity is displacement divided by the time interval. So if suppose a object is moving at non-uniform speed, okay, and we have to find out the velocity. Velocity means it is the displacement, it is a vector quantity, and we have to consider the final position and we have to consider the initial position, and we have to see what is the distance or what is the displacement from the initial position to the final position. Suppose a object is moving in this direction. So it is the starting position. Suppose O, it is first moved to suppose point A, then to point B, then again to point suppose A, and finally we have the object is at position A. Then in case of speed we have to consider the path length, okay, but in the case of velocity we have to consider the initial position and the final position. So we have to see the displacement. Displacement means what is the distance from the initial position to the final position. We need not to see the path. So from this initial position we have to see the final position. So this distance is nothing but the displacement. So we have learned about this average velocity. So if an object is changing its velocity, suppose rectilinear motion, then we can see that the object can change its speed. So we will consider one example, then we will see how we can define the instantaneous velocity. So in our previous video we have learned about average velocity. It tells about how fast an object is moving over a certain time interval. Okay, suppose this one was 1 second, this one was 2 seconds, and in the third second the object is at position this A again. After 3 seconds of time we have this much of displacement from O to A point. Okay, so here the displacement is nothing but OA and the time interval is 3 seconds. Okay, so average velocity can be calculated with this formula. So this is the formula for average velocity. It is the displacement. Displacement means final position minus the initial position, and time interval means what is the duration or what is the time taken by the object to move from this point O to point A. We can calculate the time interval for this object. If it is the initial time is suppose 0 second, then after 3 seconds the object is arriving at point A. So in this case we can see that the displacement is from O to A, and the velocity will be OA divided by the 3 second time interval. Okay, so it does not tell about how fast the object moves at different time instants during the time interval. So we have the average velocity means the velocity of the overall movement. Okay, initial position and the final position. We are not considering the different positions at what velocity it is moving or at what speed it is moving. Speed is a scalar quantity, velocity is a vector quantity. So in case of speed we will consider the path length, and in case of velocity we will consider the displacement. Okay, displacement you need not to confuse with the path length. Path length means the length of the path that the object travels. Okay, this is called as the path length. And the displacement means the initial position or the starting position, and the final position we have to see, and we have to draw a straight line from the initial position to the final position, and the length of the straight line is the displacement. Okay, so instantaneous velocity. So we have to first understand the term average velocity. So here you can see delta x by delta t. Here delta x means the displacement, how much the position is changed after certain time interval. Delta t is the time interval. Now we have to see what is the instantaneous velocity. So instantaneous velocity is defined as the velocity over an infinitesimally small time interval. So let me write down mathematically. So we can write instantaneous velocity. Suppose it is denoted with small v. Okay, so this will be equal to So first of all, we have to see delta x is the displacement and delta t is the time interval, and we have to find the velocity at certain infinitesimally small time interval. So we have to put here a limit, and this delta t, this is tends to 0. That means the time interval is infinitesimally small. Suppose during a movement, suppose a object is moving from this point A to point B. Okay, the object is moving from here to here. Its velocity might be changing. So at certain time instant, instantaneous means at certain time instant we have to find out the velocity. Average velocity means the displacement divided by time interval. Here time interval can be large, but in case of instantaneous velocity the time interval should be infinitesimally small. Here you can see delta t tends to 0. This means we have considered the time interval is very small. Let us consider one example from the book. In this figure we can see that this is the figure number 3.6. you can see here this figure number 3.6 we can see determining the velocity from position time graph. Okay, so previously we had another graph you can see from the book. So a object is moving, and here in this x direction we have the time is defined by the small t, and this s is the, it is the unit in second. That means in this along the x-axis we have the time in second unit, and along the y-axis we have x. X means this is nothing but the displacement, and here m, this m represents the meter or the unit. Here you can see the at the time, at different time the object's position is changing. Suppose at this time we can see here at time this t 3 seconds, at the time 3 seconds the object is at point P. This point is 2 meters from the starting position. Here you can see at this 3 seconds we have this is 2 meters. Again we can see at 3.5 seconds we have the object is here. Okay, at this point it may be within 3 and 4 meters of distance from the initial position. So in this way you can see how this figure is showing the position. So x is here the position, along the y-axis we have the position, and along the x-axis we have the time. Now we have to find out the instantaneous velocity. So instantaneous velocity is limit delta t tends to 0. This one is 0. Okay, and this is nothing but the, this is velocity, average velocity, and when average velocity is taken at a very small time instant, then it is called as the instantaneous velocity. Okay, so in the language of calculus what we can write, it is the rate of change of position with respect to the time instant. So here we can write this is dx by dt. This dt is nothing but infinitesimally small time interval, and dx is the change in position, or the, it is the displacement. Okay, in the language of calculus it is defined as the rate of change of position with respect to some time interval or per unit time. Suppose we need to find out the instantaneous velocity at time t equal to 4 seconds. Here you can see, let me show with another color. At 4 seconds this time we have to find out the instantaneous velocity. So here you can see this point resembles with this p position. Here you can see at this position p we have to find out the instantaneous velocity. So what we have to do, we have to draw a tangent and we have to find out the slope of this tangent. Then only we can find out the instantaneous speed. Now in this case we can consider various time interval. Okay, according to the instantaneous velocity definition we have to consider some infinitesimally small time interval. Okay, so here we are given with different time interval. One interval is from p1 to p2. This is one time interval. Another time interval is q1 to q2. This is another time interval, and another time interval is very small from t1 to t2. These are the three different time intervals. p1 p2, this time interval is larger. Okay, from 3 to 5, this is the 2-second duration time interval. So in this table 3.1, the limiting value of delta x by delta t. Delta x by delta t, it is nothing but the average velocity. at t equal to 4 seconds. When we have this t equal to 4 seconds we are given, then it is called as the instantaneous velocity. We have to find out the instantaneous velocity at t equal to 4 seconds. So in this case we cannot consider a large time interval. The time interval should be infinitesimally small in case of the instantaneous velocity. So let us consider various time intervals. So the first time interval, this delta t is time interval, t1 is the time starting time and t2 is the suppose ending time, final position. Okay, at the starting time or the initial position we have time is t1, final position we have time is t2. So xt1 is the position at time t1, xt2 is position at time t2. This is given in meter unit, it is also meter unit. Delta x is nothing but this is the displacement, and delta x by delta t, this is nothing but this is the average velocity. Okay, I hope you are getting up to here. Now in this table we can see we have to find out at t equal to 4 seconds. So when we consider this delta t time interval equal to 2 seconds, we have to consider t plus minus delta t by 2. Okay, so what will have t equal to 4 seconds here, so plus minus, so delta t by 2, delta t by 2 means here we have 2 seconds delta t value, so it will be 1. So 4 plus minus 1, so what will have from 3 to 5, the duration is from 3 to 5. So here we can see for duration, time duration or the time interval 2 seconds, we have t1 is 3 and t2 is 5. Here you can see from 3 to 5. Okay, so this is the formula for finding out the time interval. So in the first case we can see at t1 the position is, the value is 2.16 meter. So here we can see this position is 2.16 at the final position, that is 5 seconds, this position, so this is approximately, this is 10 meter. Okay, so here you can see this is the 10 meter position. So what we have to do, delta x is nothing but xt2 minus xt1, that is the position, the final position is xt2 and the initial position is xt1. So we have to subtract this xt1, that is the position at time t1, from the position at time t2. So here we'll have 10 minus 2.16, it is 7.84. This is the displacement. So if we find out the average velocity, that is the delta x by delta t, then we'll have, this is the value. So delta x is 7.84 and delta t is, we can see here, this is 2 seconds. So if we divide 7.84 divided by the 2, then it will have 3.92. Now let us consider the other cases also. In the second case, we can see here this time interval, now we are considering it is 1 second. Why we are decreasing the time interval? Because in the case of instantaneous velocity you have to take infinitesimally small time interval. So we are decreasing the time interval in this table. So in the first case we considered a larger time interval, that is 2 seconds. In the second case now we are considering 1 second of time interval. So in this 1 second time interval, what will be the starting time and what will be the stopping time or the final time? Okay, so t1 is, so what we'll have, we have to use this formula, t plus minus delta t by 2. So t is 4 seconds, because in this question we have to find out the instantaneous speed at or instantaneous velocity at time t equal to 4 seconds. So this t value is 4 plus minus delta t value, now we have, this is 1 by 2, 1 by 2 means 4 plus minus 0.5, so it will be 3.5 to 4.5. So now let us see here. So this one q, this point is 3.5 we can see, and this value is displacement here. At q2 you can see here, this is 4.5 and this is the displacement. So we have to now see these values, and the displacement is from 3.43 to 7.29. So what will be the delta x? Delta x means this is the displacement. So 7.29 minus 3.43, so we'll have 3.86. Again we have to divide this displacement with the time duration. So here we'll have 3.86. This is the average velocity. Now also we can see that this is the 1 second duration. 1 second duration is the large duration. So the duration should be infinitely small in case of instantaneous velocity. So similarly you can see for all these other cases. So this one will be the same process, this will be the same process. Now let me consider the final case. In this case we can see that this time duration is now a small quantity, 0.01. it is the 1/100th part of the 1 second. Okay, so now we can see delta t is equal to 0.01. T is already given, this is 4 seconds. We have to find out this instantaneous velocity. So what will be the duration? T plus minus delta t divided by 2. So what will have? T is 4 seconds plus minus 0.01 divided by 2. What will have? So 4 plus minus 0.01 divided by 2 means 0.005. We have 3.995 to 4.005. So plus minus this, if it is a plus, then this is the value. If it is a minus, then it is the value. Okay, so this is the duration. Here you can see 3.995. this is the starting point and the final position is 4.005. So here you can see the initial time and the final time. So these are the initial time and the final time. So what will be the time duration? So time duration is 0.01. we can see here, and xt1. Now we have this xt1 is the position at time t1 and xt2 means position at time t2. So we can see the graph here. At t1 this is the position and t2 this is the position. So this is the difference. So we have to find out the displacement. Displacement means xt2 minus the xt1. So here we have, this is the displacement and we have the time interval. So this displacement divided by the time interval, we will have, this is the instantaneous velocity. So we can consider this instantaneous velocity. Now we can see that this tangent p we are considering here to here. So now this time interval is very small, that is 0.01 second. This is a small time interval. It is 10 millisecond. Okay, so this is a small time interval and we can see that this is the instantaneous velocity. So in this way you can find out the instantaneous velocity. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel.